Hello, my name is Daniel Bruce. I am part of the Capstone 1 team working on the AmLight research project here at Florida International University. This video is I'm going to show you demos / usages of the issues we were assigned to and resolved. Now, due to the nature of some of the issues and what we implemented and how we resolved them, I cannot demonstrate every single issue as they just work naturally as the system is running, but I can show you some of them. So the first thing I'm going to show you is the minimum size test in Python Openflow. So I'm in my virtual environment in Python Openflow. I'm just going to do Python 3 setup.py and test, and I'll let it do its testing. And as you can see, we have that's not what I want. We have 392 tests passed, 46 skipped. Now this is our implementation on the right. On the left is before our implementation, 390 tests passed, but 48 are skipped. There's 2 skipped when it comes to the minimum size test. And with our implementation, we have allowed every single remaining, the 2 that are skipped to actually pass, which were the 2 when it comes to the minimum size test. So that's that. The next thing I'm going to show you is our exception hook. So, let me clear this. So over here in controller.py, I have added something that is most likely, or will, cause an uncaught exception. So if I run kaitos-d, I forgot, not in background mode, but in interactive mode, we will have the uncaught exception SumFar is not defined. Here is where I added this line of code that will cause this uncaught exception. It will provide the traceback, and if we go into where controller.py is and go into errorlog.log, we will see SumVar is not defined. That is the exception hook in action. Now, if you're actually following along just to test this yourself, make sure you get rid of this code that will cause the exception. The next thing I'm going to showcase, and it's going to be really difficult to see this, but I'll scroll all the way down. It does exist in control.py, which is the refactor for the set switch options. And as we can see here in VLAN pool, we access VLAN pool from the configurations memory instead of calling JSON loads, which actually parses VLAN pool again. And to just verify that we are grabbing the VLAN pool from our actual configuration file, in fact, I'll show you the changes in config.py, which is right here. This is what the developer suggests we move the call to, so it's only parsed once, instead of being parsed again, which we commented, which we commented out right here, and then we just load it from memory here. And here in our configuration file, we have junk data, or just random data, in our configuration file. So we're going to go up to this basic print, which will do the same thing set switch options does, and just load VLAN pool from memory and see if it loads the correct value from our configuration file. We scroll up here, the print should be at the beginning, and it is, and it matches the value VLAN pool that is in our configuration file. The next thing I will showcase is the keyboard interrupt exception in maps create. Kaitos naps create. I'm going to type in Dan and oh, wait, there's something I need to do before I create my napps. And as you can see, it displays a user-friendly message. No traceback, no uncaught exception, but it's caught and handled. The final thing I'm going to showcase is the daemon value no longer being ignored when you start Kaitos. This is a very huge bug, but we were able to resolve it. So on the left is my Kaitos configuration file. Now, before Kaitos daemon was set to false, it should not be false, it should be true. So that's one modification we did. And inside the code, we modified some statements to actually first check for daemon. Daemon is true, then we check if foreground is true, which is noted by the -f argument in front of Kaitos D. If that is true, run in foreground. If not, run in daemon. And if daemon is actually false, run in foreground. If daemon is false, then just run in foreground. So I'm going to show Kaitos D. During this presentation, there's going to be some exceptions, and that's because we're going to be running multiple instances of Kaitos, and that's just not allowed. But you'll see that in the foreground part, not in the background daemon part. So Kaitos D works perfect. If we do Kaitos D-F, get an error because of the instance of Kaitos. But as you can see, daemon is true. And with the foreground arguments, we can still run Kaitos in foreground with daemon being true. But what if we change this to false? Will it ignore it? No, we don't need a -f argument to instate that we want to run in foreground. That argument, we can just run Kaitos D, and as you can see, Kaitos D will run in the foreground as specified in our configuration file that daemon is set to false. And that is the usage and demos of the issues we were assigned to and we resolved in our Capstone 1 development. Thank you for watching.